database and SQL. Alright, this is Monday, day 6, and that is 2/6/17. Took a look at this view again of the entire look from the physical aspect where the data is actually being stored to the logical where we make all these tables, we have all these entities. Then we have a conceptual view, some type of data model where we look at the data, and we can also look at the whole thing, how we look at it from the outside, the external, how we look at it internal, and how we actually store the data. So again, here I talk about the logical view, reference how we represent the tables, but the database management system actually writes the information on some type of storage so we can retrieve it. So we are currently working on SQL. We've got assignments and so forth that allow us to do that. And so then we approach it from a couple angles. We have the design, how we design it, and then actually how we develop it. And we're going to talk more about that in a little bit. So a few more items that we're going to talk about today. We talk about constraints. How do we, what constraints do we put on the attributes? Again, the attributes define the entity. And then in here we have records or tuples. So we have a variety of terms. Entity, or often called a table. Tuples, probably more often called records. Attributes, often called fields. An entity sometimes is referred to as a file also. Now our entities can be static or they can be dynamic. And every entity must have somehow a way to uniquely identify it, and that'd be a primary key. Alright, page. So then here we have an example. We have an entity here, an entity here, an entity here. They all have those same things. A better way to put it, they all have attributes. Okay, and they all have keys. So when we take a primary key and put it in another entity, it's a foreign key. Okay. In those relationships, for example, here's a primary key that we can replace up here, an entity key. We did the example city, state, zip. But if this was representing, let's say, people in Mason City, city, state, zip would repeat and repeat, and we'd have data redundancy. So instead of having that, we can use just one thing to indicate city, state, and zip. Each item in there is a data element. And then these connections between the tables, entity relationships. And that's where we come up with the term relational database management system. Now, there's one other thing we did talk about here a little bit. We talked about a view. We can pull information using data relationships from various areas and create a view. It actually looks like a separate table, but it's really some combination from a variety of relationships. Can do that using some type of query, which we'll talk more about here. Last thing we're going to talk about, basically, how do we approach designing and developing a database. Structured top-down design, working with the client, documenting and reporting ends up all being part of this. So here's the idea. We do analysis. You figure out what the client needs. What are you trying to accomplish? You can do that graphically, have data flow diagrams, and we can define the dictionary. That's part of the documentation. The design, then we can create a logical representation of that. For us right now, we've been drawing these entities, and then between the entities we have been making entity relationships. When we develop it, we actually start building those tables and creating the relationships between them. Build it, test it, then we implement and evaluate. We put it in production, and then we see if it's giving us what we want. That can create evaluation, then creates this, what's sometimes referred to as a cycle. We see things we can improve, so we analyze them, design that solution, whatever it might be, develop it, actually build the solution, and then implement it again. And then we check it again. And this cycle can continue until we maybe eventually create a new, until we have to create a new database flow or whatever. Alright, so that is it for today.